Today we will learn how to train an image classification model using Sagemaker's inbuilt algorithm. Okay. Now, as this is a course on Sagemaker, I am assuming you already know the basics of computer vision, image classification, object detection, etc. I will try to create a separate course on the basics of computer vision. Okay. Now, for today's exercise, I have already prepared the data and created the ground truth. But those two tasks itself are big tasks and require a separate video. We will see that how to do that in a separate video. Okay, so here we have three different flowers images. This one is daisy, and this one is a rose, and this one is a sunflower. So we have a bunch of examples or images for each of these types of flowers. Okay, so at a high level in an image classification, given an image, we will try to classify the image into one of the predefined classes, are also sometimes called as labels. Okay, if we have only two classes, we call that binary classification. Then if we have more than two classes, we call it multi-class classification. Now, sometimes each image can have multiple labels as well. For example, this image, in addition to the sunflower, it might have the daisy or rose, right? So in such a case, we will have multiple labels for each image. We call that multi-label classification, right? We will see an example of that in a separate video. So I have already organized the data. Now this is how the data looks like. The important ones are just the four folders called train images, train annotations. So this folder contains the images, and this folder contains the corresponding ground truth, which we sometimes call annotations, labels, etc. Right? So the ground truth, annotations, labels, these three are referring to the same thing. Similarly, we will have validation images and also validation annotations. Okay, so those four are the required folders. I'll just show you the data. So I'm showing it local. So train images, these are the bunch of images. Each image contain one of those three flowers. Okay, and correspondingly we have train annotations. Okay, so here we have this LST list file. Now different models, they take the annotations in different formats. Again, when we work with different models, we will see what input format they take and how to create that, right? This LST format, it's for the Sagemaker's inbuilt image classification algorithms. All right. Similarly, we have validation images here and corresponding validation annotations in the validations folder. Okay. Now this file, the LST file, it looks like this. Maybe first I'll show you for the train annotations. Okay. All right. So this one, it's a 3-column file separated by tab. Okay. So the first one is simply a serial number. We have 36 images for training. So this number, it just run from 1 to 36. Okay. And the third column, it's simply the file name. Okay. This can be JPG or PNG. Again, different images can work with different file formats. All right. And then the second column, the important one, is the actual ground truth, right? Or the label. So we have this label daisy, rose, and sunflower. But as you know, computers work only with the numbers, not strings. So we have mapped those three classes into three numbers. So the first 12 images are, let's say, class 0. That would be one of the 3 flowers, and then we have another set of flowers, and finally we have the third set of flowers. Now they don't have to be organized, they don't have to be like this. I mean, they can be jumbled. It not necessary that the first set of images must all be the same class. Okay, right? So this order of these lines is not important. All right, that's the train one. Now the validation, exactly the same format, but the important thing here is this one should start with 37, I believe. It's not 36, it should start with 37. I'll check if this will not have any effect, but I think it's a good idea to start this number from 37 because we have 36 here. Okay, I thought I have started this file index from 0, but that's incorrect. All right, so again, we will see in a separate video how we prepare this file. I mean, this is easy, but for object detections, this file format will be a bit more complicated. Okay. All right, so let's go back to the code. So we have seen the data preparation, some example images. All right, now I'm going back to the code. Let me just full screen. All right. Okay, so these are standard Python libraries, the standard Sagemaker libraries. Now using this get image URI, we are going to get the Docker image, which has this model or the algorithm code. Okay. Now, as we have seen when we trained XGBoost model in one of the previous videos, what Sagemaker did is, for every algorithm, they have created a separate Docker image. Okay, and that image already have that algorithm code. Okay, so using this get image URI, by providing the model name and the model version, we will get the Docker URI. Okay. Now this one, it's just to suppress the unnecessary information like found credentials in the AWS config file. This is just the session and the role. Now I'm just reminding you again, if we are running this notebook on Sagemaker notebook instances or on Sagemaker Studio, we can get the role ARN just by using the get execution role, right? But since I am running this notebook from my local machine, I need to explicitly provide the role ARN. So I have my role ARN in bash profile. So I'm getting that value as this environmental variable. Okay. All right. Now this is the bucket name and data path, which is where we have stored the data on S3. I'll just show you. So we have this Sagemaker course, that's the bucket name, and Sagemaker classification LST format, that's our prefix. Okay. All right. So this is our bucket Sagemaker course and Sagemaker classification in list format. And then we have different folders for organizing different data sets. Okay. And then now here we have the number of classes and the number of training images. In my view, the Sagemaker should have learned these variables from the data we are providing, but this inbuilt algorithm, these two variables are required arguments, so we need to provide them explicitly. But there are other models which can infer the values of these two variables from the data we are providing. Okay. All right. This is the number of epochs. So the number of iterations the model should get updated or trained. And this one is the mini batch size. So what happens is, let's say we are using 100 images for training. So instead of using all 100 images for learning and then updating the weight, what the model does is it divides the number of images into mini batches of size, in this case 8, and using every 8 images, it will learn, it will update the weights, and it will do the feedback mechanism, etc. So that way model learns much faster rather than learning from all images at once and then updating the weights. All right. And then this is the instance, one of the cheap instances for GPU instances. Now, the computer vision models, they require a GPU, unlike tabular data models, which can work with the CPUs. Okay. Now, here I have provided a link. Maybe let's go to the link. So here you will see the price. So for training instances, a different price. For inferences, different price. The batch or the data processing, etc., etc. Right. So today we are looking at training. Now all these are generic CPU instances, and these ones computer optimized but still CPU. Now these ones are GPU instances. Okay. Now, depending on if we are doing transfer learning or how much data we are using for training, we might want a bigger instance. But for this model, the images are just 36, and those are extremely low resolution, really small size images. So I'm using, I think this instance, which is the cheapest one. Well, this one. 4 and 32. Yeah, this one. ML G4DN X large. Okay. So it cost about 0.7 US dollars per hour. Okay. All right. Let me go back to the code. All right. And then we are defining a prefix for the job name. So the first thing, we want to get the Docker image, right? So using this image URIs retrieve, here we provide the model name and the model version. So we want to train an image classification model. This is an inbuilt algorithm by Sagemaker. But if it's from other library, we typically have the prefix, maybe TensorFlow, PyTorch, HuggingFace, etc. Right? And in most cases, we probably be using the latest version. But if for any specific reason you want a specific version of the model, you can provide the version here. Okay. Region, that's a default parameter. Now, there are two values per the scope. One is training, the other one is the inference. This point is very important because it will determine how we deploy the model. Okay. Now, for the inbuilt algorithms, the same instance is used for both training as well as inference. Whereas if it's from a third-party algorithm, then the training instance and the inference instance will be different. And for those, we also need to provide what's our endpoint, the model artifacts as a zip file that we will cover in the next video. But today we are using the inbuilt algorithm. So it makes a lot of things easy for us. Okay, we don't need to provide any entry points, the model artifacts, I mean the source model artifacts, etc. explicitly. We just need to get the image URI. Okay. So this is that image URI. So basically this is the ID, Docker, ECR means Elastic Container Registry. This one is our region name. And then this is the standard Amazon AWS.com. And this is the model image classification. And this one is referring to the latest version. Okay. Now, don't worry about this message because this function is so generic. the parameters it takes, they depend on what we are trying to do, right? For example, if it's a tabular data, we don't need GPU. Maybe if it's a again, if we need GPU, the information here will be slightly different, okay? But don't worry about it. All right, and then we need to define a path where we want to write the model artifacts. Okay, that's the path. So within the same folder and prefix, we are asking SageMaker, hey, create a new folder called model output and store my model artifacts there. All right. Then we are defining this SageMaker or the classification estimator. Now the important by providing the image URI. Okay, the image URI, which is this. All right. And then as standard ones, role, the instance count. Again, if this model can be trained in parallel, we might use multiple instance. A good example would be random forest, where the trees are trained in parallel, right? Now the training instance type, which we have discussed before. And again, a couple of these parameters are really standard. So this is the external EBS volume size, the file mode. Now, this estimator can take the data in different formats. For example, there is a record IO format. TensorFlow has its own format, etc. But we will work with the file format so that we can, it's easy. Now, when we have large data sets, really large data sets, the record IO other formats are more efficient for reading large amounts of image data. But typically, when we work with our custom data sets, and we will be using the transfer learning, meaning we will be training only for a few steps using probably not more than 1,000 images. The standard file format also works fine. So it won't make much difference reading the data time. Okay. And this is the output path in the standard session. Now, here we set the hyperparameter. So as we discussed, the number of classes and the number of training images. So this first one and third one, these are required parameters. But for some other models, the SageMaker or the models, they directly interpret these values, this value from the ground truth file and this one from the images folder. Okay. But for this inbuilt algorithm, we need to provide these two mandatorily. And here we have the number of epochs and then the mini batch size. Now, this one is the most important one. Here we are saying use pre-trained model is equal to 1. What that means is we are saying I want to do transfer learning. So what it means is now this model has, this resonance model has 18 layers, right? So when we say we want to use transfer learning, the first 17 layers and their weights are frozen. Frozen means those weights don't change during the learning, the model learning process. So what happens is the 18th layer are also called head layer. It's removed from the neural network architecture. And then a new layer is created with the number of nodes equal to the number of classes. So what happens is the output from these 17 fixed layers, it gets fed to the final layer, which is where the classification happens. So all the learning process of finding the patterns in the images, finding the features, curves, etc., the specific things related to different classes, etc., happens within the first 17 layers, and the last layer only the classification happens, right? So for that reason, we can use only few images, and also the number of epochs can be a few. Okay. Whereas if we are training a model from scratch, we might be requiring tens of thousands or even hundreds of thousands of images, which is what they have done when these original models are trained, and the number of epochs will also be quite high. Now, again, don't worry about most of these parameters. Those are standard and default values. The learning rate, probably you can play with the learning rate. So choosing a high value, the solution jump from one what is called local minima to another local minima. So the solution don't converge to its best state, which is global minima, right? Now, if we choose a small value, the number of epochs are it will take quite more time for the solution to converge. Okay, that's learning rate. Another important parameter, this multi-label one. So as we discussed, an image don't necessarily be labeled or mapped to just one label. It can have multiple labels. For example, one of the flower images we saw, it can have both, let's say, daisy as well as rose, right? So in that case, the image has two labels. So for that, we will set it to one, and the ground truth format will also be different, that we will discuss when we train a multi-label image classification model. Okay. All right. Here we are just setting some paths. So as we have discussed, we have a bucket, we have a data path, and then we organize the data into 4 different folders. We have training images, training annotations, validation images, validation annotations, right? So we just define those 4 paths here. And then the SageMaker has this method training input. So where we simply supply these paths here, right? So here we are saying, okay, train images, that's of type training input, and here we are supplying the S3 path where we have the training images, and then this will change depending on the data format. Here we are saying it's application JPEG. There are a couple of formats like X image. I think that will work with JPEGs, PNGs, etc. So that's probably more generic. And then the data type S3 prefix, right? So for all the image related projects, in most cases, these 3 will remain the same. We just provide the paths. Okay. So those are the 4 paths we have provided. And we have the 4 variables in this training input method or format. Okay. And then we are simply creating this data channels with the 4 variables. So here we have train. Now these are important. The key values should be exactly the same, because when we train the model, when the data from all these gets downloaded to the training instance. So as you know, the training is going to happen on a different instance, right? So this notebook or this instance, it's just acting well, from here we are executing only some commands, right? But there is a separate instance where the actual training happens. So the data from S3 gets downloaded to that instance, the training happens there, and the model artifacts from that instance are copied back to S3. Okay, so when that instance try to download the data, it will look for these key values. So these 4 key values are very important. And I find some models, they have slightly different key values. For example, I think TensorFlow model, it requires training as a keyword, not just train, right? And it don't require this LST format input. Okay, and we'll see that in the next video. All right, and then we have a job name prefix. So we are creating a unique job name just simply by appending the current timestamp, right? And that's it. We are simply fit. So this fit method, just like in scikit-learn, it will train the model. Okay. So yeah, it's saying, okay, I'm going to train a model with this job name, and it will prepare the instance using that algorithm or the Docker image. It will download the data. It will verify the data is in the right format, etc. And it will train the model. Provide quite detailed logs. In one of the videos, we will see how to analyze this, how to access these logs from SageMaker CloudWatch logs, and do some plotting, etc. But one of the most important ones for these deep learning models is this epoch value and this validation accuracy. Okay, because we are training this model for 10 epochs, So here we have this final, the validation accuracy, some 87%, right? So the model has trained and the artifacts are uploaded back to the S3 location output path, and that complete the training job. Here it will show you the billing seconds, okay? The training and billing seconds, often these values are very close. All right. So we have trained the model. Let me show you. Control. So we have defined the model output, right? So these are all different models I have trained. So let's look at one of the recent ones. Maybe this is Jumpstart TensorFlow inbuilt ResNet. Yeah. So this is how it looks like. Profile output. One second. It should have 3. Maybe that one failed. Okay. I was expecting another folder called output. So not this one. Profile output. Okay. Maybe let's. Okay, this also has 2. Yeah, so if the job is successful, it will look like this. Okay, there will be this additional, this is the important folder output. Here is where the model artifacts are. Okay, so our bucket name, the prefix, and this is our output path, model output, and then it will create a folder with the training job name, and then it will have multiple folders in it, but the important one would be this output, which is where the model artifacts are stored. All right. Now, that's how we train a classification model using Sagemaker inbuilt algorithm. Now, we'll quickly, the focus of this video is not deploying our inference, but I will quickly show you how we do that, right? So if you want to do an inference, obviously we need to define an instance type where we want to run the inference. We need to create the model. So we have created the model artifacts, right? Now we need to create a model name. We need to create an endpoint config and endpoint, right? But we are deploying the model directly from the estimator. So when we do that, the SageMaker, it automatically create a model for us, and then an endpoint config, and finally an endpoint. So which is what happening here. So we simply provide how many instances we want for inference and the instance type, and we are supplying the endpoint name and the model name. So, okay, so this one, the estimator, it already know which image to use for inference and where the model artifacts are, because we are still working within the notebook, right? And then it will create these 3. Okay, so we have created an endpoint. Now, in order to make the inferences, we'll have the SageMaker runtime client. So using this Boto3 client, we're accessing the SageMaker runtime. Okay, SageMaker runtime, and then we can invoke the SageMaker runtime by providing the payload, which is image in this case. So here I have an image, local image. Okay, so just read the image and convert it to bytes array. And now we are calling this endpoint, and this this can take the input in the image JPEG format, and the output will be this JSON format. And then this is the actual image content, right? Then we get the response back. The response will be standard Python, the Boto3 SDK format. It's a complex dictionary with lots of metadata information, etc., etc. But the prediction we are looking for, it will be in this response body. It will be again in this binary. We are just decoding that binary string. So we get the probability for the 3 classes. Okay, so the first one is almost negligible. The model is very certain that it belongs to class 1. So let's say this is class 0, 1, and 2. The class 1, we can map it back to the name or the string. It will be one of those 3 flowers, right? And as we discussed before, we get charged for these endpoints because those instances are dedicated for us. So even if we are not doing any inference, we get charged. So it's important we delete the endpoints. Okay. So when we delete, the model don't get deleted. So when we deploy, three things are created, right? The model, endpoint, config, and endpoint. So when we delete the endpoint, only the endpoint and endpoint config gets deleted, but the model we created, it will remain there. Okay. Uh, yeah. So as we discussed, as I said, the focus is not so much the inference, the model training. Probably already a quite long video, but in the next three videos, we are going to train another image classification model using TensorFlow, and then an object detection model, again inbuilt algorithm as well as TensorFlow. The process will be very similar, so you get used to it and it becomes clear, and you will start to see the patterns, how SageMaker standardize the model training process, so that when we know how to train one model, uh, training other models also becomes easier. Okay. That's all for today. Thank you very much.